Okay, so today what we're going to do is learn how to calculate and determine how much time it takes for our shutter mechanism of our disposable camera to go from the open position to the closed. And so here I have the housing of the disposable camera. We see the shutter arm is right here. It's currently in the closed position. So I can swing it to its open position. All right, we're going to be calculating the amount of time it takes to go from that open position to that closed position. And so you see that the shutter arm is actually connected to the housing at this one point right here. The one thing that you will notice that's missing from my housing is a spring that goes from this point right here, which is connected to the shutter arm, down to this point right here, which is on the housing. But of course that shot across the room right before I made this video. All right. So how are we going to do this? Well, step one, what we're going to want to do is study the stiffness of the spring. And so the equation that is of interest to us to start out is that force, F, is equal to our stiffness times our change in length, or delta x. And so we need to determine all three of these variables. Okay. What you're going to see in the overview document is that you are provided with an initial length of the spring, and then you also see lengths of spring that are associated with hanging masses. All right. What we want to do is first, to determine x, we want to take those lengths. All right. And so we've got a series of lengths, and the first thing we want to do is take those lengths, which are in inches, and convert them to length in meters, so that we're using our SI units. Okay. The second thing we want to do is note that we have lengths here, and so what we actually want are change in length. So what we want to do is take these new values of x and subtract our initial length. All right, and I'll just call that xi. And what you'll see in the document is that our xi is equal to 0.16 inches. So don't forget to convert this as well to meters. Okay. We can then determine our three change in lengths. Okay, and so you should get these new change in length variables. Okay, so now we have our change in length. Next, we want to determine what our force is. And so we're actually provided with hanging mass in grams. So the first thing we want to do is take those masses, which are in grams, and convert those to mass in kilograms, because we are using our SI units. Okay. We then want to determine what our force is, and so you're all familiar from physics with force equals mass times acceleration, where in this particular case acceleration is equal to gravity, which is equal to 9.8 meters per second. Okay. Again, everything in SI units. All right, so to determine our force, we can now take that hanging mass, all right, multiply it by our gravity, and get our force in newtons. And that's our SI units for force. Okay. So we now have our force values, all right, and our change in length values. Okay. We can now plot these values to determine what our stiffness is, which is the slope of the line. So what you're going to do, scroll up here a little bit, is create a plot in Excel where your y-axis is going to be your force values, and your x values are going to be your delta x values. And what you'll see is that you'll get 3 points. They should be pretty linear, and you'll be able to plot the line. Okay. Do not use 0, 0 as an automatic point. You cannot make the assumption that that is a point on your line. Okay. Use either the 3 data points provided to you in the overview document, or collect your own data by taking your spring and using some hanging masses. So we'll have some hanging masses in classes that you can hang from your spring, and just simply using a caliper you can measure out what that new length is, and then of course determine what your change in x is. Okay. So one of the questions you have is to determine whether or not this goes through 0, 0. Okay. Now, when you get your 3 points and you plot them, all right, in Excel, you can then do a trend line in Excel, and that will help you determine what your slope is, and the slope is your K value, all right? That is your stiffness value. When you plot your trend line, you'll see an option to be able to plot the equation of the line, and this is a linear relationship between force and your change in length. We know this because if we go back up to our equation that we're provided with, all right, we see that y is equal to mx, and then of course you can have an offset, all right, if this doesn't go through 0, 0. It would be 0, but there may be a value there if it doesn't go through 0, 0. Okay, so if it goes through 0, 0, you'll have a value of 0. But we don't know that yet. Okay? So that's one of the things that you'll be determining. So you'll find the equation of your line and you'll determine what the value is. And so now, all right, if you are provided with some value for x, okay, you can determine what your corresponding force is. Okay, so you'll see that you have additional questions that relate to if the length is, in this particular case, 0.5 inches, all right, what is your corresponding force? And all you have to do is put that value into your equation that you have here, all right, that you've determined, and you'll be able to calculate your force value. Okay, so this will get us started off in step 1 in terms of determining what the amount of time is for this shutter mechanism to close.